about that. So the last thing we need to do is this example. And for whatever reason, I didn't get it copied onto the notebook file. So this is also on the topics page for chapter 10. And it's just this chocolate chip cookie example here. So, okay. So the situation here is these two students want to know if generic chocolate chip cookies have as many chocolate chips as name brand chocolate chip cookies on average. So to investigate, they randomly select 10 bags of Chips Ahoy cookies and 10 bags of Great Value cookies, and then they randomly select one cookie from each bag. Then they carefully break apart each cookie and count the number of chocolate chips in each. So here are the results. So they're giving us the actual data here instead of the statistics for these samples, which often when you see this means you're going to put all this information into your calculator and do box plots. So here we go. We're going to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. So that means construct and interpret. That means we're going to do our state plan, do, conclude. So for state, we will estimate, because it's a confidence interval, we will estimate the true mean difference, mu C minus mu G of chocolate chips in each brand of cookie at a 99% confidence level. And then we introduce this notation here. So we need to define this. So mu C is the true mean number of chocolate chips in Chips Ahoy. And then mu G is the true mean number of chocolate chips in Great Value. So we plan to use a two mean t interval. So we have to check our conditions first. So we have a simple random sample of 10 cookies from Chips Ahoy bags. We have an SRS of 10 cookies from Great Value bags. In terms of being independent, we are going to assume that there are more than 10 times 10, which is 100 Chips Ahoy cookies in the population, and we will assume the same thing for Great Value cookies. Our population shape is unknown. They did not tell us anything about the population shape. And both of our sample sizes are 10, which is less than 30, so we need to do box plots of our sample data. And I think this is already in my calculator. Let me see. So to put all the information in our calculator, we're going to go stat, edit. Now in this case, we have two different samples. So L1, I put all my Chips Ahoy cookies, and L2, I put my Great Value cookies. So we have two samples, so we need these to be in two separate lists, okay? We don't want to do the difference, sorry, those are my cats. They're upset because I haven't fed them yet. We don't want to do the difference between them because we have two different samples that we're talking about. And at the end of the chapter, we'll talk a little bit more about how to make sure you know which inference method to use. So I want to do a box plot of these. So if you go to second y equals, you actually need to turn on two separate box plots for each list. So for my L1 list, I did that in this first one. So I turned my plot on. I want my box plot with the little outliers there on. And then for this box plot, I'm going to use L1. And then I'm going to do the same thing for the second one. I turned my plot 2 on. Again, I want my box plot with the outliers, and then you have to make sure you tell the calculator, use the list from L2. Okay, the default will be L1. So if you graph your two box plots and they look exactly the same, then you probably forgot to change one of them to L2. So then, when I do zoom 9 to graph them, both of my box plots show up. Okay, and then I can trace and I can get, all the information that I need. All right. So, and it tells you this one was L1, so that it's always a good idea. I didn't do this on here, but it's always a good idea to say like, okay, for this one I used L1, and for this one I used L2 to jot that down just to keep yourself straight. So my two box plots here, again, you need to make sure you have your horizontal axis labeled. You need to show on the box plot which is Chips Ahoy and which is Great Value. So for both of them, because there's no strong skewness, there's no outliers, that means we can use our T procedures. Okay, so we stated, we planned, so now we have to do. So we're going to use data, so see above. We're going to go back to that calculator. Okay, so there's our lovely box plots, get out of there. So I'm going to go to stat, test, and then again it's 0. So I should have gone the other way maybe. So this is a two samples T interval, right? Because it's means and we've got two samples, we're doing confidence interval. And so I'm going to use data because I have all that data in my calculator. My list 1 was I put L1. My list 2 was L2. The frequency is always going to be 1. My confidence level it said in the problem to use was 99%. And then you're never going to use pooled data. Okay, so I don't really even know what that is, but just don't use it. So we hit calculate. Come on. And this is our confidence interval, okay? Again, there's our degrees of freedom. So it's not n minus 1, all right? We had a sample of 10 from each of these, but it's our degrees of freedom isn't 9 because it had that funky formula that it used. This is the mean of our sample for Chips Ahoy cookies. So on average, they had 18.4 chips. For our Great Value cookies, on average, they had 19.4 chips. There's our sample size. Okay, all that good stuff. So this is what you write. So data, see above. There's my confidence level pooled. No, I did not pool it. This is my crazy degrees of freedom, and here's my confidence level. Okay. So to conclude, we would say we are 99% confident that the interval from negative 4.814 to 2.8138 captures the true mean difference, mu c minus mu g, in the number of Chips Ahoy, in the number of chocolate chips in Chips Ahoy versus Great Value. That's our conclusion. Okay. And then this last little part says, does your interval provide convincing evidence that there is a difference in the mean number of chocolate chip cookies? Well, 0 is in the interval, right? So because 0 is in the interval, there's not convincing evidence that there is a difference. So it looks like more often than not, well, I shouldn't say that. It looks like there's a range of values in my confidence interval where Chips Ahoy cookies have less chips. There's a range of numbers in my interval where where Chips Ahoy cookies have more, but then there's also the possibility that they're equal. So that's all we have to say for that. This one we're not going to do yet, so we're not there yet. Sorry, I didn't mean to put this in there yet, but we'll get to that during the next class. So that's the last little bit from 10.2. We're just talking about confidence intervals today. Next class we will talk about significance tests. Hopefully this made sense and a lot of it's familiar, and the homework is online. And I will see you guys next week. I hope you have a really good long weekend.